Hi, this class we are going to talk about work power energy related problems. When work is said to be done, what is called work? You are applying a force. Because of the force, there should be a displacement. Work is said to be done when a force is applied and the body should be displaced. This is the basic information for work done. So, work done is a product of force and displacement. Correctly speaking, work done is a scalar product of two vectors. That is, W is equal to F vector dot S vector. That is Fs cos theta. Work done is a scalar. Force and displacement are vectors. Two vectors. But work is a scalar quantity. Depending upon the value of theta, W will change. Generally, we will discuss two cases, major cases. Very rare, theta is equal to 180. Theta is equal to 0. Along the direction of force, the body is displaced. Theta is equal to 0, W is equal to Fs. Perpendicular direction between force and displacement, theta is equal to 90. Man is carrying a load on his head, walking. Physics wise, he is not doing any work because force and displacement are perpendicular. So work done is 0 in this case. Okay. Power is rate of doing work. Rate of doing work, we call it as power. Work done is Fs. This is by T. S by T is nothing but velocity. So we can write power is equal to the scalar product of two vectors, force and velocity. Then energy. Capacity of doing work, we call it as energy. Capacity of doing the work, we call it as two different forms of mechanical energy. That alone we are going to talk here. Mechanical energy, that is kinetic energy and potential energy. Energy possessed by the body by virtue of its position, we call it as potential energy. Potential energy is force into displacement. A body is raised to a height, then the force is nothing but the weight. So MA is replaced by MG. The displacement is nothing but the height. So the potential energy is MGH. Kinetic energy is energy possessed by the body by virtue of its motion. You call it as kinetic energy. Half mv square. Half mv square is kinetic energy. Sir, we need the relation for kinetic energy with respect to momentum. Momentum is P is equal to mass into velocity. So in terms of momentum, if you want to write kinetic energy Ek, that is P square by 2m. P is nothing but momentum. M square V square by 2m. M cancels, half mv square. Okay. So using these three basic formulas and information, we are going to do problems related with work, power, and energy. Now we'll go to the problems. First problem. A gardener pushes a lawn roller through a distance of 20 meters. If he applies a force of 20 kilogram weight in a direction, inclined at 60 degree to the ground. Find the work done by him. Basic formula, work done is equal to Fs cos theta. W is equal to Fs cos theta. What is the force given here? 20 kilogram weight. 20 kilogram weight means 20. W is equal to M into G. This is work done. This is work done. Weight W is equal to F, that is mg. 20 into 9.8. Work done or energy. Displacement here given as 20 meters. Incline at an angle of 60 degree, cos 60. So 20 into 2400 into 9.8 into cos 60 is 1 by 2. So 200. 2 into 980. 1960 joules. 1960 joules spent by the gardener. It pushes a lawn roller through a distance. What is the work done in pushing? That is the question. So he is giving 1000, he is spending 1960 joules in pushing that one. Okay. Next. A person is holding a bucket by applying a force of 10 Newton. He moves a horizontal distance of 5 meter and then climbs up a vertical distance of 10 meter. Find the total work done by him. Second problem. A person carrying a bucket of water moving in a horizontal distance. Horizontal distance carrying a bucket, already we have discussed. He is not doing any work at all. Physically he is doing some work, but physics wise no work is said to be done. So work done by the person is 0 in the first case. So W is equal to Fs cos theta. What is the force here? 10 Newton. Displacement is 5 meters. Cos 90, that is 0. W dash F S dash cos theta dash. Then he climbs up. What is the distance he is moving? 10 meters he is moving. So F is 10. This is also 10. Along the direction of force, body is moving. Along the direction of force, body is moving means theta is equal to 0. First case, theta is equal to 90. Second case, theta 0, cos 0, 1. So it is 100 joules. So when he is carrying a bucket of water, walk for some distance and then climbs up. The total work done is 0 plus 100. First case, no work is done. Second case, 100 joules. So total work done is 100 joules in this case. Okay, fine. Third one. A force F is equal to I plus 5J plus 7K acts on a particle and displaces it through S is equal to 6I plus 9K. Acts on a particle, displaces through. That means force is given, displacement is given. Calculate the work done if the force is in Newton and displacement is in meter. Same formula, but vector product we have to use. I mean, two vectors multiplication. Scalar product of two vectors we have to do. W is equal to F vector dot S vector. Basic formula. What is force? I plus 5J plus 7K dot 6I plus 0J plus 9K. So 1 into 6 plus 0 plus 9 into 7 joules. 7 into 9, 63 plus 6, 69 joules work is set to be done. Here, instead of giving the force in terms of Newton and displacement in terms of meters, we have given in vector form. You have to express after multiplication of scalar product only by Newton and meter. But before that, you have to express in IJK form cross product of two vectors. It is not cross product, it is dot product of two vectors. Scalar product you have to calculate, then final answer. Concept wise same. Same work done. Fourth problem. A man moves on a straight horizontal road with a block of mass 2 kg in his hand. If he covers a distance of 40 meters with an acceleration of 0.5 meter per second square, find the work done by the man on the block during the motion. This is straight. The man is moving a block on a horizontal road. Force is given, displacement is given. Horizontal road means along the direction of force the body is displaced. So basic formula W is equal to Fs cos theta. Here Fs theta. What are the values? 2 Newton, 2 kg, 0.5 acceleration, displacement is 40 meters. F is equal to MA, 2 into 0.5, 1 Newton. Displacement 40 meters. Theta is equal to 0. Therefore, W is equal to 1 into 40. 40 joules. Straight problem. 40 joules of work is set to be done in moving a block in the horizontal. Okay. Fifth problem. A force F is equal to 2I minus 6J Newton is applied on a body which is sliding over a floor. If the body is displaced through minus 3J meters, how much work is done by the force? F is formula W is equal to F vector dot S vector. Instead of given force and displacement directly like in the previous problem, they are given in the form of IJK form. So the force given is 2I minus 6J dot. What is the displacement? Minus 3J. So we can write 0I minus 3J. So first is 0, second is minus 6 minus 3. So that is 18 joules. 18 joule of work is to be done in this case. Okay. Sixth problem. A body of mass 4 kg initially at rest is subjected to a force of 16 Newton. What is the kinetic energy acquired by the body at the end of 10 seconds? Mass is given, force is given, time is given. Mass is 4 kilogram. Force, time. What is the force? 16 Newton. Time is 10 seconds. You have to calculate kinetic energy. Kinetic energy is half mv square. So velocity we have to calculate. To calculate velocity, we want to know the acceleration. Because force and mass is given in the problem. Therefore, acceleration is force by mass. What is force given? 16. Mass is 4. So 4 meter per second square. Okay. Next. V is equal to U plus AT, equal to motion, you know. Body starting from rest. Starting from rest means U is equal to 0. So I can write V is equal to AT. V is equal to A is 4, T is 10. So 40 meter per second implies kinetic energy is half mv square. Half into mass is 4, V is 40 square. 2 into 1600. 3200 joules. Three different things here we are calculating. Three things we are calculating. Number one, acceleration. Number two, velocity. And number three, kinetic energy. All the three we have to calculate. Okay. Next, seventh problem. A shot traveling at the rate of 100 meters per second is just able to pierce a plank 4 centimeter thick. What velocity is required just to pierce a plank 9 centimeter thick? Shot traveling at the rate of 100 meters per second, able to pierce a plank of 4 centimeter. You have to calculate same 9 centimeter thick. What is the velocity necessary? Question number 7. A bullet is shot. It pierces a plank of some thickness. Velocity given. Next, plank thickness is given. What is the velocity? This is the question. So first, half mv square. Same mass, same bullet. So mass is same. Kinetic energy and another case is work done against the plank surface. Work done is nothing but force into displacement, Fs. Same case, both the cases, force is same. So this is S1. Half m V2 square is F into S2. So V2 square by V1 square is equal to S2 by S1. V2 by V1 is root of S2 by S1. V2 by V1 is equal to root of S2 by S1. What is the displacement? 9 centimeter. Previous one is 4 centimeter. Root of 9 by 4 centimeter get cancelled. So that is 3 by 2. V2 is equal to 3v1 by 2. 3 into, what is the first velocity given? 100 meters per second. 100 by 2. So it should be 150 meters per second. This is also kinetic energy. Work energy concept, work energy theorem is this problem. Work is said to be done, energy is released. Oh. Eighth problem. Two bodies of masses 1 gram and 16 gram are moving with equal kinetic energy. Find the ratio of magnitude of their linear momenta. Two masses 1 gram and 16 gram given, moving with equal kinetic energy. Ratio of momenta we have to calculate. Kinetic energy, we have two formulas. One is half mv square, or kinetic energy is p square by 2m. Ratio of momenta is asked. So, therefore, equal kinetic energy p1 square by 2m1, p2 square by 2m2. p1 by p2 the whole square is equal to m1 by m2. p1 by p2 is root of m1 by m2. Straight from. What are the masses given here? 1 gram and 16 gram. Root of 1 by 16. That is 1 by 4. So ratio of momenta is 1:4. In this problem, the ratio is 1:4. Correct? Straight substitution. Question number 9. While catching a cricket ball of mass 200 gram, moving with a velocity of 20 meters per second, the player draws his hands backwards through 20 centimeter. Find the work done in catching the ball and average force exerted by the ball on the hand. First, we have to calculate the work done. Second, we have to calculate the average force exerted. Question number 9. Work done is equal to kinetic energy. Work done is equal to work energy theorem. Work done is equal to kinetic energy. That is half mv square. Half mass is 200 gram. 200 into 10 power minus 3. Velocity is 20 meters square. 20 meter per second. 20 the whole. 0.2. 0.2 and 2 is 1 by 10. This is 400. So 40 joules. Work done is 40 joules in this case. While catching the ball, the work done is 40 joules. What is the average force exerted? That is the second part of the question. Force is work done by displacement. Work done is 40. What is the displacement in this case? Taken his hands through a distance of 20 centimeter. Is taking and moving through a distance 20 centimeter. Actually, once the ball comes to rest like this, he can hand. So, after reaching his hand, the velocity becomes 0. At that moment, he is not keeping like this, he is dragging for some distance. So, you have to understand the difference. Sir, while catching ball comes to rest, and where is the question of velocity and all? While moving only it comes to change. After coming to rest, the person is moving his hand. Simply is not catching like this. Okay. This is what we will study in impulse. Impulse is force into time. Why always a person while catching a cricket ball, moving his hand without get hurt? Why? You are allowing more time for the ball to move his hand. So if you keep it more time, the injury to the hand is very less. Impulse is force into time. So force is equal to impulse by time. When the time spent is more, what will happen? Force is automatically reduced. So you will get less injury to the hand while catching the ball. Same case in the case of wrestling. Two persons are doing wrestling on the sand floor. When they come down to the ground, what is happening? Sand means the body is dragged for some distance. It is not the normal mosaic or tiles floor. Okay. So sand means the body is dragged. Body is dragged means it spends more time on the ground. More time on the ground means injury is less. This is the concept of impulse. Okay, coming back here, force is 40 and the displacement is 20 centimeter, 0.2 meter. 2 by 10, 400 by 2, 200 Newton. 200 Newton force is exerted. Okay, 10th one. A ball bounces to 80% of its original height. What fraction of its mechanical energy is lost in each bounce? Where does this energy go? Potential energy, 80% of energy is lost at the first bounce. 20% of energy is lost in the second. Okay, question. What fraction of its mechanical energy is lost in each bounce? Potential energy only lost because when it is dropped, it has to rise to a height. 80% lost means potential energy, mechanical energy, kinetic energy, and potential energy. Potential energy 80% is lost. Potential energy 80% is lost. That is, what are the data given? After first bounce, potential energy is 80% of mgh. 80 by 100 into mgh. Let it be mgh. No problem. It bounces 80% of its original height. 80% bounces of its original height implies 20% lost, not 80% lost. When the ball is put it just dropped means 80% it bounces back, 20% is lost. He turns around at the time of striking, heat energy with the ground when it is touching the ground. Definitely some sound is coming. These two forms, energy is lost. 20% energy is lost. So what is a fraction? fraction of fraction lost is, how to calculate? Actual is mgh and the lost is 20% into 20%, that is 0.2 mgh. mgh already up. These two cancels. Fraction is 0. Total always will be in denominator. What is the outcome is in numerator. Okay. Question number 11. A stone of mass 0.4 kilogram is thrown vertically up with a speed of 9.8 meter per second. Find the potential and kinetic energies after half second. Mass is given 0.4 kilogram. Speed is 9.8 meter per second. Find the potential energy and kinetic energy after half second. 11th question. Potential energy is mgh. So the displacement first we have to calculate, then only we can calculate the potential energy. Displacement is ut plus half at square. The body is rising. Here A is equal to minus G. So S is equal to ut minus half gt square. What is the velocity initial? 9.8. Half a second. So 1 by 2 minus half G is 9.8 half square. So S is equal to H. 9.8 by 2, 4.9 minus 1 by 4, this is to 9.8 by 8. Simplify. 3.67 meter total. To simplify this value, it is 3.67 meters. Therefore, potential energy is mass. What is the mass given? 0.4 kilogram. G is 9.8. H is 3.67. So multiply, you are getting the answer 14.386 joules. Simple multiple. Instead of giving the height directly, you have to calculate using the basic formula S is equal to ut plus half at square. Okay. This is the first part. Second part is kinetic energy is half mv square. Half mass is 0.4 kilogram. What is the velocity given in the problem? Not given. Initial velocity only given. V is not given. So we have to calculate V is equal to U plus AT. A is equal to minus G, as you know. So we can calculate 9.8 minus 9.8 into half. 9.8 minus 4.9. That is 4.9 meters per second. Once you know the velocity, kinetic energy can be calculated. Half mass is 0.4, 4.9 the whole. 4.9 the whole. Simple. So 4.802 joules. Straight. Okay. Fine. 12th problem. Calculate the work done in lifting 300 Newton weight, a height of 10 meters with an acceleration of 0.5 meter per second square. Take G as 10 meter per second square. You have to calculate the work done in lifting the body. Work done in lifting the body, W is equal to mgh. But here it is not G alone. You are lifting it. So you are giving some acceleration and then the body is raised to a height. Here two things. Work done is mgh. Acceleration plus G. Okay. So first mass M is equal to, this is work done. This is mass is W is equal to mg. This is W by G. What is the value? 300 Newton. This is to be taken 10. So it is 30 kilogram. Therefore, work done is equal to 30 into A. What is acceleration given? 0.5 meter per second square plus 10 into the height is 10 meters. 300 into 10.5. That is 3150 joules. This is the work done. Correct? Shades up. 13. A 16 kilogram block moving on a frictionless horizontal surface with a velocity of 5 meter per second compresses an ideal spring and comes to rest. If the force constant of the spring is 100 Newton per meter, then how much is the spring compressed? $16 kilogram block moving on a frictionless surface with a velocity of 5 meter per second. Compresses an ideal spring and comes to rest. So energy here is kinetic energy converted to the electrostatic potential energy. It is elastic potential energy. Elastic potential energy. If it is a charge, means electrostatic potential energy. Half kx square. Kinetic energy is half mv square. So half kx square is equal to half mv square. Half cancels. X square is m by k into v square. X is equal to root of m by k into v. What is mass? 16 kilogram. Spring constant 100 into the velocity given as 5 meter per second. So I can write 4 by 10 into 5, 20 by 10, that is 2 meters. The compression is 2 meters in this case. Okay. A lift is designed to carry a load of 4,000 kilograms through 10 floors of a building, averaging 6 meters per floor in 10 seconds. Calculate the power of the lift in HP. Horsepower you have to calculate. Power P is equal to work done by time. Work done is mgh by time. P is equal to mgh. Okay. The value of m here is 4000 kilogram. G is 9.8. Height 6 meter per floor. 6 meter per floor. So H here is 6 into, we have totally 10 floors. So total height only we have to calculate. We have to substitute into 10. So 4000 into 98. 4 into 98. So that should be 388 into 10 power 3. 392. First, this is in watts. 1 horsepower is equal to 746 watts. So 1 watt is 1 horsepower by 746. Therefore, power in HP is 392 into 10 power 3 by 746. This you simplify 315.3 horsepower. We can write in watts as well as in horsepower, anything. You want to convert with this formula you have to use and then substitute. Basic. 15th. One pulley takes 1 minute to raise a box through a height of 2 meters. Another takes 30 seconds for the same job and does the same amount of work. Which one of these two has a greater power and which one uses greater energy? Both pulleys here in this problem, both pulleys doing the same job. Lifting and then moving. One person is taking 1 minute in lifting and then moving. Second person is taking fast in 30 seconds itself. So, we will do the problem. By simple logic and common sense, we can come to the conclusion that previous thing is 1 minute. Second one is 30 seconds. So, second one power is double that of first. Simple. Okay. So work done by the case, both are same, power into time, P2, T2, P1, T1, both are equal. P2 by P1 is T1 by T2, 1 minute by 30 seconds. So 60 by 32, P2 is 2 P1. So twice the power and twice the energy. Okay, Mama? State problem, simple common sense. 16th problem. A car of mass 1000 kilogram accelerates uniformly from rest to a velocity of 54 kilometer per hour in 5 seconds. Calculate its acceleration, gain in kinetic energy, average power of the engine during this period. Here, neglect the friction. That is the question. Friction to be neglected. Mass is 1000 kilogram, velocity 54 kilometer per hour. Velocity 54 kilometer per hour. 54 into 1000 by 3600. Cancel. This is 18 into 10. This is 3 times. 3 by 2 into 10. that is 15 meters per second. So we have converted that velocity in terms of meter per second, the first point. Then we can do whatever we need. Acceleration, first part, v minus u by t, 15. What is the time taken? Of course, initial velocity is 0, time taken is 5, 3 meters per second square. Second, gain in kinetic energy. Half m v square minus u square. Final kinetic energy minus initial kinetic energy. That is called gain. Half m. What is the mass? 1000 kilogram. This is 15 square minus 0. 500 into 225. Gain in kinetic energy. Multiply and then calculate. 1.125. 5 into 225. 1125 into 10 power 2. 1.125 into 10 power 5. This is second part. Third, power. Power is simple, work done by time. Here work done is nothing but kinetic energy. Convert of kinetic energy only work done here. 1.125 into 10 power 5 by time taken is 5 seconds. 1125 into 10 power 2 by 5. 100 by 2 is 20. 1125 into 20. 2250 into 10. That is 22,500 joules. This is power arm. So I can write watts. If not asked means you have to express in watts only. If it is asked to convert in terms of hours power means you have to convert into hours. Okay. So these are the basic examples for work power energy chapter. In detail, we have discussed about the concept of work done and what is the energy supposed to be calculated in terms of kinetic energy, potential energy, total energy, and finally the power in terms of watts as well as in terms of horsepower. Okay, thank you. Welcome.